Let's try to learn some of those basic graphs, right? Because as I said, the moment we think about graphs, don't always think like I need to create a bubble chart or I need to create a heat maps, right? Again, there is a very common misconception in the world saying that you need to come up with a fancy charts. Guys, business people are very simple, right? As long as you're able to tell the story, right? As long as you're able to talk sense, right? Or else you are trying to talk about the things that they are not aware of. In a simple and easy way, they would be very good and happy. Don't think that you need to impress them with respect to a complex graphical representation where itself it will take an hour time to explain the graph, right? The moment you flash a graph in front of someone, that should tell the story for you, right? You should not spend 2 hours of time in explain the things. Then the initial phrase that we started, right? A picture is worth 1,000 words. It will go away, isn't it? Right? So do not show all your technical prowessness and talking about the graphical representation, right? Tell the story simple, right? You can make use of these basic common graphs which can tell the story very good. Now let's just start the journey with respect to the first graph, which is called line graph. Guys, have you ever come across graphs? Line graph, right? Maybe as part of your metrics, as part of your PM or as part PMO teams or etc. We always try to be dependent upon the line graphs. What does it try to tell you, guys? Any idea? These are some of the basic things that we already might have developed as part of your reporting teams or etc. Guys, what do we use line graph? Where do we use it and why do we use it? Anyone? It's not out of the box that we're trying to learn today, but guys, what is a line graph?
It shows the fluctuation.
It shows the fluctuation. Decent enough. Anyone else? No? Okay. So the moment we talk about line graph, right, it is trying to display the information as a series of data points called as markers. Okay. And which these markers are connected by the straight line. The moment you see such kind of a representation of your data, we call them as line graphs. Since I'm trying to talk about a series of data points and I'm connecting those data points using the straight lines, is this used for continuous data or categorical data?
Continuous.
Continuous.
It has to be used on the continuous. It means the moment you're working on a continuous data and you wanted to show the trend of a particular thing, we always use a line graph. Okay, so the basic use of line graphs is it will be useful for us to observe the trends over the time, right? So as an example, let's say there is a particular organization, right? They are just trying to track about their revenues. Say what happened in 2008, what happened in 2010, what happened in 2011. So in those cases, what will happen? You can draw a simple line graph saying that, okay, in 2008, I made a revenue of maybe $15,000. In 2009, I made a revenue of 20,000. So this is how all individual data points could be marked as a marker. Okay, and these markers can be easily connected by the straight line. So historically, if you try to order this particular data with respect to the time, you'll be able to get a nice trend, whether my sales are increasing trend or they are decreasing trend. Okay, makes sense? Guys, are clear? So line graph is basically used for the display of the information on a continuous data as a series of the data points called as markers, which are connected by the straight lines. Okay, so since we are trying to talk about the line graphs, if the data has been captured with respect to the time scale, it should be ordered with respect to time scale. So what does it mean? I cannot put like a 2020, then 2018, then 2016, then 2021, right? It does not make sense. The moment you're trying to observe the trends, the data has to be ordered by the time scale. Clear about this? Any questions? What is line graph and why it is used? To observe the trends first. Are you clear about this, guys? Appreciate your response.
Yes, Danish.
Dhanush, why are you saying it as a time scale? It can not be just years, right? It can be any other data, isn't it?
Yes, as I said, the moment we talk about trends, right? So the trends are basically be used with respect to the time, right? What happened over the period of time, isn't it?
Yeah, but we can also kind of map with respect to index, in other words also, right? Not only with time. I'm just trying to understand if I'm missing anything there.
No. What I'm saying, like the best usage of your line graphs is to observe the trends. So since I'm trying to talk about the observation of trends, so definitely I'm trying to relate this to the time scale. If you want to talk
Okay.
about other than time too, you can always do it. But what is the usage of it? What you're trying to get is what I'm just trying to emphasize here. So one of the most
Gotcha.
common uses of line graph is to observe the trends over a period of time.
Okay. Gotcha. Thanks.
Yeah. Now move to the second graph, which is called as an bar graph. Guys, why do we use the bar graph? Any idea, guys? Guys, we work with respect to all these graphs before, isn't it? But I see absolute silence in today's session, but I'm not sure. How does the
For
bar graph?
Comparison.
range between two ranges.
Can you come again?
Usually it's like between between values like range 10 to 20, 20 to 30, like that.
No. It is not called as a bar.
For comparison purpose.
Okay, but how it is? How would it look like?
For a particular product category. Something.
Okay, to keep it very simple, yes. So a bar graph will contain a bar. This particular bar is going to represent each category of a qualitative data. Guys, what does a qualitative means? It means it contains a discrete categorical or finite set of values. The moment you have such kind of a variables, bar graph is the one that you need to make use of. So a bar graph contains a bar for each category of a set of a qualitative variable. So basically it is used for continuous or discrete or categorical data. Nice. A bar is going to represent each categorical value of a qualitative data. So the reason it is used for continuous or categorical data.
Categorical data.
It is obviously used for your categorical data. So should I be worried about the time ordering here? Since I brought this particular dimension in the earlier case?
No.
No, definitely it's not a mandatory because we are dealing with the categorical data. And what is the usage of it? Since I talked about the line graph to observe the trends, so why am I using the bar graph here? What is the usage of it?
To show the distinctions between uh, two products or
Simple. So when we say distinction, it is all about comparison, isn't it, guys? Yes or no?
Yeah.
Right. So the
Yeah.
more you're trying to have a different categories, I'm just trying to compare those categorical values, how they are varying. Say as an example, there is a team of nearly 200 people. Now I wanted to select what is the most liked fruit among this particular bunch of people. Right. I'm just trying to give some options. It's a apple, orange, banana, kiwi, blueberries, or grapes. So what will happen? Each one of those people who are participating in the survey, they try to opt for one of the fruit, right? And what do? You try to represent each one of those category. What are the categories here?
fruits.
The fruit names, right? The apple, orange, banana, whatever I just talked about, those are nothing but your categories. So each category will have its own bar. And what is the length of the bar that is going to decide? How the length of the bar will be decided?
By number
Maximum.
like
Simple. So it means it all depends upon the number of people who has chosen that particular fruit as their favorite, isn't it? So to keep it simple, the length of the bar is nothing but equal to the count of the people who are trying to opt for a particular fruit as their favorite. So this is how you can make use of a bar graph when you're dealing with respect to categorical data. And if your objective is to compare the things, right? You can always opt for bar graph. Make sense? Are you clear about this, guys? Are you clear?
Yes.
Very good. Now coming to the pie chart. Any thoughts, guys? Have you ever seen a pie chart before?
Yes. Like percentage out of 100, how many?
Excellent, right? So it means even pie chart is being used for qualitative data. The pie chart is being used for with respect to the categorical data, but the only change here is most of the times, if it is with respect to frequency, if it is with respect to just accounts, people prefer the bar graph. But the moment people want to represent this particular categories in the form of percentages, people generally prefer the pie chart. So the use case wise, it is pretty much similar to your bar graph, except that if you wanted to represent, right, in the form of a percentages and a little different way, we can always prefer a pie chart, because each slice of the pie represent a category, and each category will try to tell you the percentage. It does not mean that you cannot use for the frequency. You can still use the frequencies, but what happens, we generally try to call the full pie as 100%, and each slice of the pie will try to represent a portion, a subset of the entire information. Okay guys, make sense? So the use case wise, it is very much similar to the bar graph. And if you're trying to deal with respect to the percentages more, people generally tilt towards the pie chart to tell the same story. Okay, make sense guys? All clear?
Yeah.
Okay, so the use case could be like, maybe I'm just trying to look for, everyone is using their laptops, and I'm just trying to be doing a little survey saying like, hey, out of this a number of people that they are trying to participate in the survey, I just want to know people are using which particular internet browser. Maybe they are using Firefox or Chrome or Opera or Safari or Internet Explorer, right? So which particular percentage of the people are more tilted towards a particular browser. So this is how I can make use of a simple pie chart here to represent this data as one whole pie. And I'm just trying to talk about each slice is going to represent one particular browser. Okay, and finally what we get is a percentage of the information. Makes sense guys? All clear? Any questions here? Excellent. Now coming to the histogram, Juhi, this is for you. Go ahead.
Um,
Whatever the answer that you gave for bar graph, right? You can continue the answer for histogram.
Range.
Yes.
Range.
Yes. So basically, what is the difference between histogram and bar graph? In case of a bar graphs also, I'm trying to make use of the bars as part of my representation. When it comes to histogram, again, here in this particular graph also, I'm using the bars for my display. But the only change here is histogram is for category, sorry, bar graphs are for categorical data, whereas for your histogram, I'm trying to use it for quantitative data. When I say quantitative data, it is nothing but your continuous data. But how can I draw a bar for continuous data? Guys, is it possible for me to draw a bar for each continuous value?
No.
No, definitely not. Say as an example, I'm just trying to measure the height of 30 people, or maybe I'm just trying to measure the height of 100 people. What happens? The height of the people could be as low as 170.12 or 175.36, right? If I'm trying to talk in terms of centimeters, right? So is it possible to draw for each one unique value of the continuous values, guys? Does it make sense? Does it make sense? Because the height might range all the way back to 142, 180 centimeters or 190 centimeters. Definitely does not make sense. Right? I will not be able to build any story out of this. So this is what I do. I try to change these continuous values into the concept of bins. These bins are also called as classes. It means I'm going to take the range of values, I'm going to take a range of continuous values, and I'm going to divide them into classes or bins. So as an example, as I said, maybe the height of the people might be starting at 130 centimeters or 140 centimeters, right? I might make 140 to 150 as one bin, 150 to 160, 161 to 170, 171 to 180, 181 to 190, right? Now what I call them, these range of values are generally called as classes or bins. So these are generally listed at the bottom of the graph, and the classes with higher frequency will have taller bars. Pretty simple. Make sense, guys? Are we clear? Did you get a difference between a bar graph and a histogram? Bar graph is for categorical data for comparison purposes. Whereas your histogram, a histogram is a graph. It is also using bars for its display, but it is used for continuous data, and the continuous data has been converted into classes or bins, right? And the a particular class which has more number of people as part of this will get the tallest bar. Are you clear about this? Any questions? Please stop if you're not able to follow. Appreciate everyone's response, guys.
Yeah, okay.
How about others? I see it's not even Monday morning, so definitely there should be
Question,
more
sir.
enthusiasm in the section. Go ahead, very good. Any questions here, guys? I see someone talking. Okay, Bindu, since you understood about this particular concept, what it is used for then? I explained what is histogram and how it is different from your bar graph, but what is the usage of it? What are you going to get as part of these particular histograms?
Like comparing some products in
The moment you talk about product, is it a continuous value?
no, discrete. And
I gave you an
like
example.
in
See,
2018,
let me just help you a little. I talked about a problem of heights of people, right? I gave a range of 130 to 180 or 190. Now work on the same problem. Tell what are you going to get finally. How this particular graph will be useful to you. Nice, anyone? It's
It
open to
can
everyone.
help in
Helps
a
us to
selection process like that.
One at a time, please.
Best height and least height, something like that. I mean to
You'll
say.
not be able to talk about it because see, Jilani, it would be a range of values, right? So if I say 180 to 190 is one bin, now how could I be able to get the highest value or be the best value I was trying to talk about? It is a group of values together, isn't it? People who are falling under 180 to 190 will be represented by a single. If I'm trying to survey 100 people, maybe 180 to 190 might have 6 or 7 people, right? So the respective y-axis will have only things. Agree, Jilani?
Yeah, Dhanush.
Again, the power of connecting the dots. I don't know how many of you are able to remember the third section of your descriptive statistics. You should be able to talk about this. All your prior sessions should be readily available in your brains so that you will be able to connect the dots easily. No one in the class session, guys? Interesting. Okay.
So,
Go ahead, Jitendra. Give it a try.
yeah, yeah. So, as we are dividing into different intervals, like 130 to 140, 141 to 150, like that. So, we will place the values into that interval. So, we'll get the heights. The values will be fall into that class intervals. So, values will be arranged in a height order. So, we'll get the heights of the histograms.
Very good. But if you can elaborate a little, the answer would be perfect.
So on the x-axis, we'll have the class intervals.
Yeah,
So
see, you're
we'll
explaining what it is. I'm saying why it is used or where it is used. Your answer, you are trying to explain how the graph is being built. That I already explained, right? Okay, guys, let me not.
Can I answer, sir?
Okay, so to keep it very simple, right? It is going to help you to get the shape and the spread of the data.
Shape.
Right? The shape is very, very important angle, right? You cannot always bank on central tendency value. You cannot always bank on a particular value, right? It is all about you are going to get an entire understanding on the shape and spread of the data. Why? Because I'm going to talk about all the 100 people and their respective heights. Right? I was able to get a nice shape like how the data is varying. Right? Okay, I see like people. Maybe if I try to survey maybe 10th class students, maybe the height is trending over maybe 150 or 160 centimeters more. Oh, okay. It means it is going to give you an idea saying that okay, people are most commonly found with respect to these height limits. Make sense, guys? So you're going to get an entire understanding with respect to the shape and with respect to spread of the data. Make sense? Clear? Because you're not going to talk about a particular range, right? You're going to talk about the entire range of values, right? From the smallest value of 130 to the highest value of 190, as an example. Make sense, guys? Are you clear? So a curve which is going to be drawn around this histogram peaks is generally called as distribution curve. Again, I'm going to explain about distribution curve later, but since we talked about histograms of a continuous values, the moment you draw a graph through all those peak points for each one of those bars, it is generally called as distribution curves. And the example that I have taken is, I'm just trying to survey, say as an example, heights of 30 people, and I'm just trying to talk about the limits over there, and I'm just trying to capture the frequency. Okay, guys, now looking at this graph, Jilani, can you comment about the skewness of this data? What is the skewness of this data?
Q to right.
Very good. You see these guys? Am I not getting the shape of the data? Yes or no? Yes or no?
Yeah.
You see this? Under the section of shape, we have learned about this. Agree? So this is how your histograms is going to talk about the entire shape and also spread of the data. How the spread of the data is being there, right? It is sparsely populated towards the right. So there is called as the right skew data. Okay. Now move to the next important graph, scatter plot. Guys, have you seen the scatter plot before, or is it the first time that I'm trying to introduce this particular graph to you? Have you seen a scatter plot before? No? Interesting. How many say no? As part of the program, did I expose you to the scatter plots before?
Yes, it The was in assignment on problem is covariance when given it as a is less near to than zero. flat.
Guys, can someone talk one at a time, please?
Sorry. It is in covariance when
Very good.
zero.
The first time that we have seen about the scatter plots is covariance. At that point of time, I didn't name it as a scatter plot, but actually I was trying to talk about the relationship between two variables, x and y, or it could be x1 and x2, right? We're able to see a lot of data points which are having the intersection of those x and y values, and those are nothing but a scatter plot. The other day that what we have seen is today, right? The moment we started the journey, it is all about scatter plot, isn't it, guys? Right? It is going to display the data that is paid by using a horizontal and vertical axis. It means it is going to provide the relationship between two variables only. Make sense? Are you clear? So scatter plot is not new to you, even though we have referred to them, but we have never named it as a scatter plot. So the moment you wanted to provide the relationship or association between two variables, you can make use of your scatter plot. Are you clear about this, guys? Are you clear?
Yes.
Yes. Now, Mohan.
Yeah, Dhanush.
So since I'm trying to talk about the relationships, how many types of relationships can I find between two variables?
Two, three.
Only two? Three. Very good. Can you please name them? I've seen this before. Don't get confused.
Yeah.
What are the three types of relationships that we have seen before when we're discussing covariance and correlations?
One is independent.
Mm-hmm.
One would be positive and negative.
Okay. Why such a long pause, Mohan? Just trying to understand.
No, I'm just trying to recollect.
Okay. Okay then. Okay. So the moment we talk about understanding the associationship or relationship between two variables, it all falls around the positive, negative, and independent. When I say independent, there is no relationship between them because the data is spread across multiple ranges of your X and Y values. You could not figure out what kind of a relationship is it. So in those cases, we call them as no relationship or independence. So the other way, right? It means without even calculating the correlation value, even without calculating the covariance value, by just looking at a graphical representation, can we comment about the relationship, guys? Is it possible for us to comment? Yes or no?
Yes.
Yes.
Right, so that is the beauty of your visualization. It means even without, right, talking about a certain kind of an calculating those numerical measures, we can still comment about the relationship just by looking the trend of those particular graph. Right, even today, right, we were able to talk about the relationship, isn't it? It is a band of a straight line, right? It is a curvilinear line, right? It is the absolute straight line with one outlier, right? So this is how you can comment about the relationship even without calculating the correlation or covariance values. Okay, so if you ask me, right, if I can put like this, maybe I can select a non-linear relationship too, right? Because that could also be, right, instead of saying non-linear, let me say curvilinear relationship, because not every time, right, we might not be able to talk about in correlation terms, right? Sometimes I said there's a non-linear relationship which is nothing but a curvilinear relationship as you have seen in the graph B. Okay, are you clear about this? Any questions here?
Yeah.
Okay, so when you look at a particular graph, how can you say whether there is no relationship at all? So for us, right, there is a very easy way to the moment you see a circle, the moment you see ellipse, the moment you see a square or rectangle, when you see such kind of an shapes on the data, we can definitely conclude that there is no relationship between those two variables, and we can claim and say that those two variables are independent of each other, right? I'm just trying to give you an example, right? So how can you say whether there is a relationship or no relationship? The data is pretty much scattered, but there is a very generic term that we have to use. So instead of that, I say the moment you see a circle shape, the moment you see a kind of an elliptical shapes, the moment you see some square shapes, right? As per the data points, you can definitely conclude that there is no relationship between two variables. Okay. And what is the other advantage, guys? What is the other advantage or the byproduct advantage that you get the moment you use scatter plots? Do you see any other advantages as part of the graphs that I've shown either today or the last session?
We can avoid the outliers,
Okay,
unuseful.
we cannot say avoid, we can say we can find outliers, isn't it?
Okay.
Yes, yes or no? So as part of the graph C and graph D, were you not able to identify the graph outliers? Yes or no?
Yeah.
Right? So in the graph C, a data point which is having the X value of 14 and Y value of 14, it is behaving little extremely or anomalously compared to the other data points. So similarly on the graph D, a data point around 19 to 14, right, is the one which is spread or maybe which is getting deviated from the other data points. So this is how the other advantage of your scatter plot is you can always use it for you to find the outliers or extreme values. Make sense? Clear? Guys are clear on this? Appreciate your responses, guys. Are we clear on this?
Yes.
Very good. Now moving to the next one, right? Box plot. So till this particular point of time, yes, when I'm trying to draw these graphs, am I using any of those numerical measures to draw the plots? No, right? So when you are trying to make use of your box plot, right, it is a standardized way of displaying the distribution of the data, making use of your numerical measures. It means I'm going to make use of the minimum, maximum, median, mean, IQRs, Q1, Q2, and Q3. It means if you have to draw the box plot, you need to have the complete information about your data. So the reason, the one of the best plot that you have to make use of is box plot, because it is will help you to get a better understanding on the entire data distribution. It is not just a graphical representation, it is making use of your numerical measures plus a graphical representation together, so that you'll get a complete understanding on the data distribution. So the result is one of the very standard graph that I generally prefer. The moment I wanted to, the moment I'm working on a continuous data, the moment I'm trying to understand the data distribution, I generally prefer the box plot. because it's such a nice visual way of trying to represent the data, not only the graphical representation, but it will always have the numerical values associated with this graph. In with respect to any of the other graphs, am I using any of these values, guys? Am I using any mean? Am I using any IQRs? Am I using any Q1, Q2, Q3 values?
No.
No.
No, right? So this is the only graph which makes use of this numerical measures plus data visualizations together, so that you're going to get the benefits of the both the worlds. Okay, so the reason it is one of those very important plot for you to get a better understanding on the data distribution. And as I said, it is going to make use of some of those standard numerical measures for displaying the data. So what are the measures that I'm going to make use of? I'm going to make use of minimum. As you know, Q1 is nothing but 25 percentile, Q2 is nothing but median or 50th percentile. I'm going to make use of Q3, right? I'm going to make use of max value, I'm going to make use of minimum value, I'm going to make use of IQRs. So these are the different numerical measures that I'm going to make use of to display the information. Okay, and when I'm going to talk about this, right? So there are two other terminologies that you need to remember. One is called lower fence. Guys, what do you mean by lower fence? Do you remember from your high school mathematics? The moment we are trying to discuss about box plot, you need to understand the lower fence and upper fence. So the lower fence is generally calculated as Q1 minus 1.5 distance of your IQR. And the upper fence is generally called as Q3 plus 1.5 times of your IQR. So this is how your statisticians came up with a concept of lower fence and upper fence, and any data points which fall below this lower fence sorry guys. So any data points which are falling below this lower fence and above this upper fence, they can be called as, they can be identified as, can someone name them?
Extreme values.
Excellent, right? So any data points which are falling above and below this lower and upper fences, they can be identified, they can be called, they can be tagged as extreme values or outliers. Make sense, guys? Are clear?
Yeah.
Okay, this is like a reference ranges, right? So the moment you try to calculate them, you're going to get a couple of values called lower fence and upper fence. Any data points which fall either above this lower upper fence or below this lower fence, we call them as extreme values. Are you clear about this, guys? Any questions? So this is how a box plot will look like. Okay, so the box, what you see is nothing but it has four values to it, right? The upper vertical line, so the upper horizontal line is generally called as Q3 value, which is nothing but upper quartile or 75th percentile, and the lower horizontal value of the box is generally called as Q1 value, which is also called as lower quartile at 25th percentile value, and the middlemost value, the horizontal line in the box, is generally representing as median value. So this is how the box is going to give you three values, Q1, Q2 and Q3 values together, and you see the left hand side, I call them as Q3 minus Q1 is nothing but my interquartile range. Now the dotted line, what you see is generally named as upper fence and lower fence. Okay, it means it is 1.5 IQR distances above the Q3 and 1.5 times of lower than your Q1 value. So any data points that you see above these two fences are generally called as outliers. Now in this particular graph, how many outlets are there? What's the total number of outliers?
2.
Two, right? You see two small dots over there. Instead of dots, right? They're small boxes. Okay, so, but generally those are being represented as dots when you're trying to make use of any programming language visualization skills. So this is how any data points which are falling above these fences or below these fences can be termed as outliers. Clear about this, guys? Are you good?
Yeah, okay.
Okay, so this is all about your data visualization that I have thought of discussing today. So this is such an important concept. Don't think that data visualization is always for the business teams. Yes, business always understands graphs better than the statistical test names or the results, right? But at the same time, as a data scientist, first you need to get a better understanding of the data, right? You cannot browse through 1 million records or 200 variables to get an understanding of the data, right? the two ways of trying to get an understanding of the data is always using the numerical measures and try to understand the same data using the graphical representation also. So this is how you'll be able to get the both worlds of the knowledge, and you'll be able to get a better understanding of the data. Are you clear about this, guys? Any questions? A small chart which is going to tell what is your objective. Based upon that, you can pick n number of graphs. As you know, graphical representation of data vision itself is a huge specialization, but as I said, being a data scientist, right, working on such kind of a simple graph should be good enough for you to tell the